2.4, dividing polynomials, remainder, and factor theorems. I'm going to be honest, guys, when I pull up these notes and I see it's 3 pages, I might get slightly more excited than you do when you notice that it's only 3 pages. But let's plug and chug. Let's get through this thing and we'll learn some more, right? So I think some of this is review for you. I'm hoping some of it's review, but it may be some brand new stuff as well here. So we're talking about dividing polynomials, long division, synthetic division, using a remainder and factor theorems, okay? So long division of polynomials. I'm going to really stress to you here, this is not hard if you totally understood long division when you were in 3rd or 4th grade, okay? Place values and making things in the right place is so huge when you're doing long division of polynomials. So one of the big things we have to do is arrange the terms of the dividend and the divisor in descending powers, right? So we always want it in standard form, highest to lowest power. What is also super important is that if a power is missing, we need to actually put it in there with a coefficient of 0, okay? So keep that in mind that we need every descending power all the way from the top to the bottom of our polynomial. We're going to divide by the first term in the dividend by the divisor, and we're going to go through and we're going to go one term after the other. The key is front term and front term only, okay? And as we do this, hopefully I can stress that and that'll make more sense. So these steps are here. I'm going to be honest, watching me walk through it is hopefully a little more helpful than just trying to read these steps, okay? So let me move my paper and let's get started. So long division, just what we think it is. We have the first number is always underneath my division. X squared is the highest power, 14x is the second highest down to my constant, and I'm going to divide by this x plus 9 on the outside. Okay, now key thing here, you look at your front term only, and the first term that you're trying to divide into, okay? The rest will work itself out, but we don't concern ourselves with that as we go through this division. So I'm asking myself, what should I multiply x by so that I can get x squared? Okay, I'm going to multiply it by x. I need to put that x above the x's over here. Okay, so columns and keeping these in order are super important. Okay, now that I decided I'm dividing, that I go x, I'm going to multiply this x up here back times my x plus 9. So x times x is x squared. I put it underneath the x squared. X times 9 is 9x. I put it underneath the other x term. Just like in regular division now, I'm going to subtract what I just multiplied through. So you can leave the subtraction on the outside, or you can do a plus, and we can do a minus and a minus, okay, to kind of keep our signs straight. So x squared minus x squared, it's gone, which is good. We wanted it gone. 14x plus the negative 9x leaves me with 5x, okay? And then I bring my next term down. Very similar to long division when you bring just the next number in the line down, okay? All right, once again, I look only at my front term, and I look at this and I say, what should I multiply x by to get 5x? Well, it looks like a positive 5. So important to keep that sign on there. Positive or negative, whatever it is, put it on there. It looks like a plus or minus once we get it on there. All right, 5 times x is 5x. 5 times 9 is 45. And I'm going to subtract this whole entire term or that I just found. So remember, that's plus, and it's like the negatives. So 5x plus negative 5x, it's gone. 45 plus negative 45, it's gone. That means I have no remainder. When I divide it here, my answer is x plus 5. Okay? And just a reference, if you took x squared plus 14x plus 45 and you tried to factor it, right? If you think about this, it factors to factors of 45 that add to make 14, that'd be 9 and 5, right? Both are plus. So if I divide by this one, which is what this problem said, then I should get this one left over as my answer. So algebraically, it's making some sense here what we're getting when we divide. Okay, let's try number 2 here. A little bit longer and a few things we need to be careful of. Okay, so top one is what I'm dividing by, so that goes inside. I have a 2x to the 5th minus 8x to the 4th plus 2x to the 3rd plus x squared, and it stops. However, there's more powers left, so we have to do a 0x and a constant of 0, okay? You have to keep listing all of them. So sometimes those zeros are in the middle if something's missing, but no matter what, from the highest, you have to go down all the way to the lowest power, which is your constant, which is your x power of 0, basically on that variable, okay? And I'm dividing by 2x cubed plus 1. Okay, once again, I can't stress enough, it's all about this front term, okay? The 1 plus 1 will take care of itself as we go through, but it's all about that front term. So the first thing I look at is that front term and the very first one. What do I need to multiply 2x to the third by so it matches 2x to the fifth? And the answer here is x squared. So watch this. I have to put it all the way over here on top of this x squared, okay? All the rest of those do not have anything above it. It's like saying I'm going to divide, 1,306 by, 95. Well, I can't divide those first two numbers by 95, so I keep going to the next place until I can divide it out, okay? So again, think of this as long division, even what you learned way back in elementary school. And we have to really watch those place values. Here, it's not so much a place value as it is a power value for whatever exponent we're on. All right, x squared times 2x cubed is 2x to the fifth. I put it right underneath it because it matches. X squared times 1 is x squared. And notice I put it all the way over here under x squared, right? And I'm going to subtract that whole term, okay? I'm lining up like terms, and that's super important. So when I add the opposites here, 2x to the fifth minus 2x to the fifth is just 0. I have to bring down negative 8x to the fourth. I'm bringing down plus 2x to the third. And x squared plus negative x squared disappears, okay? So I'm going to just kind of hang that out right there and leave it. I think I'm going to need to bring down this 0x, but just remember, this one's a little bit funny because we had that big gap already. So let's see what happens next. Okay, first term, 2x to the third. What do I multiply it by to make negative 8x to the fourth? Well, 2 to negative 8, I need to multiply by negative 4. And then x to the third needs to multiply by x to make x to the fourth, so I get negative 4x. All right, negative 4x times 2x to the third gives me negative 8x to the fourth. Negative 4x times 1 gives me negative 4x. So that's all the way over here. And I'm going to subtract that whole term. When I subtract, that means opposite here, and that becomes plus. So negative 8x to the fourth plus 8x to the fourth cancels, which is what I was hoping for. 2x to the third just drops down. 0x plus 4x makes 4x. And once again, I bring down my next term, which is 0. Okay. I still keep going because I still haven't gotten smaller than what I'm dividing by. So what do I multiply 2x to the third by to make 2x to the third? Well, that'd be a plus 1. So I'm going to squeeze in my plus 1 here. 1 times 2x to the third is 2x to the third. 1 times 1 is 1. Put it over here underneath the 0, which is a common term it lines up with. I'm subtracting. Okay, subtracting means add the opposite. So 2x to the third minus 2x to the third is gone. I bring down my 4x, and 0 plus negative 1 is minus 1. Okay, I get down here to the bottom, and you'll notice that now the power of what I'm trying to still divide into is smaller than what I have in my divisor. So because of that, I cannot go any further. What I have right here, this is my remainder, okay? And remember, not all division comes out equal, not even with polynomials. So you can get remainders, okay? Key thing is how can I write this answer with this remainder, okay? And I do want to stress this. So when I divided by 2x to the third, I got an answer of x squared minus 4x plus 1 plus the remainder, which is 4x minus 1, still being divided by 2x cubed plus 1, okay? I leave it. That is not divisible. I can't go any further, but it's still part of the answer. So instead of just putting that big, the big R like we did once upon a time when we were in elementary school, we're actually going to write it of what the remainder is over the divisor. Okay, so here's my final answer. Okay, long division. I'm going to be honest, number 1, I normally wouldn't tell you to do long division on. Number 2, definitely, because of that odd power that we're dividing by, that 2x cubed. The x cubed is something that it makes it more difficult to take into our synthetic division that we're learning on the next page. So this is a method, the long division. When the powers get bigger that you're dividing by, you really need to use this long division. All right, let's move to page 2 and our synthetic division, okay? All right, synthetic division here. What I'm going to stress to you is when you're dividing by a factor of something to the first power. If it's not the first power, don't use synthetic division, okay? We really have to stick with x to the first power or whatever variable we're working with, okay? So I set up my notes a slightly different here, okay? You'll notice that I have these 7 steps, and if you follow them, you can do this. I'm going to kind of go through one at a time. So again, I'm hoping my example will be a little more clear to you than the rest of it, than just the words itself, okay? So sometimes it helps just to hear and see these examples. Okay, once again, arrange the polynomials in descending powers and with a 0 coefficient for any missing term. So just like we did on that last one, you have to include every term from the highest power down to the constant. You have to, every time. And if it's missing, we have a 0. Okay, so I look at my problem for number 3. Cubed, squared, to the first power, no power. So everything looks good there. I don't need to do anything there. We're going to write c for the divisor, x minus c. This is super important. This is right here is my c. It is always opposite the sign you see, okay? Because if you think about it, x minus c equals x minus 2. So it's always going to be there. So my c this time right now is 2. If I had positive 2, I'd have to flip it and make it the opposite sign, okay? So we always put our divisor up here in this little left-hand corner in a box, okay? And now we're going to write the leading coefficient of the dividends. Oops, this one does not go to that. We're going to write the coefficients of the dividend all the way across. So just the coefficients. We're ignoring the x's and stuff. So my x cubed is 5. My x squared is negative 6. That negative is so important. Do not drop that sign. My x is positive 3. My constant is 11. So I put all of those across the top. Okay. Now, here we're on to step 3. Write the leading coefficient, the dividend on the bottom row. We always drop this very first one just straight down. And nothing else happens to it. It drops straight down. Now, if you can kind of follow me here, I take my first one, my divisor up here, and I multiply it by my number down here. So 2 times 5 is 10, and I put it underneath the negative 6, okay? So I multiply, and then I just put it up here. Now I'm going to add coming down. Negative 6 plus 10 is 4, okay? Now once again, I take this number over here, and I'm going to multiply it times the 4, which is 8, and just put it up here. I'm going to add coming straight down, so I get 11. I take my corner number, and I multiply it times that 11, and I get 22, and I put it up there. And then I add coming straight down, and I get 33, okay? All right. So just so you're kind of following here what I just did, I just went through step 4, step 5, and repeated this until I got all the way to the end, okay? So I've just done step 4, 5, and 6. That's what you just saw me do, 4, 5, and 6, okay? Now, we're going to use the numbers in this last row to write the quotient plus the remainder above the divisor, okay? This is where it's super important. The degree of the first term of this quotient is 1 less than the degree of the first term from before, okay? So think about this. Up here, this 5 went to an x cubed, right? So now that we divided, I'm going to go to this first one goes to an x squared. So I get 5x squared plus 4x plus 11 with a remainder, so I get 33 over my divisor of x minus 2. Okay, so this last number is always the remainder. Okay, so if I would have just set this up under long division and did the same exact problem, this is what would have been across the top, this would have been my remainder, and I put it over my divisor. Okay, was this faster than doing the long division? I would say so, right? It keeps us a little bit more short, and to be honest, it's like a shorthand of it, okay? That's what we're doing. Okay, so let's try it again with number 4. So remember, this is like saying I'm dividing by x plus 2, right? And that's the same thing as saying like minus negative 2, right? Plus is a minus negative 2. So if I say x minus c, my c this time is the opposite sign, which is negative 2, okay? So if you can kind of see where I'm getting that opposite sign, because of the plus 2, I put a negative 2. Whatever the sign is, opposite in the box. Okay, my highest power is to the 7th, and that has a coefficient of 1. I have nothing to the 6th power, so I'm going to put a 0. Okay, that's my x to the 6th. It's missing. X to the 5th has a coefficient of 1. X to the 4th is missing, so it gets a 0. X to the 3rd is negative 10. X squared would be the next one down, and it's missing. X is missing. And I go all the way down to my constant of 12. A lot of zeros here. That's okay. You have to have from the highest power all the way down. You cannot skip those, okay? So we start at the 7th, 6th, 5th, 4th, 3rd, 2nd, 1st, no power, okay? It's important we have all of those. Okay, first one drops straight down. Then we start this multiplication to put right there, okay? I'm not going to keep drawing my lines because it gets confusing, but I want to make sure you feel. Negative 2 times 1 is negative 2. I put it underneath the second column. 0 plus negative 2 is negative 2. Now I go to my corner and multiply again. Negative 2 times negative 2 is positive 4. I put it underneath my next column of 1. 1, we always add these in here. So always multiply coming down, always add coming straight down, okay? If that makes sense. 1 plus 4 is 5. 5 times negative 2 is negative 10. 0 plus negative 10 is negative 10. Negative 2 times negative 10 is 20. Negative 10 plus 20 is 10. Negative 2 times negative 10 is negative 20. Did I say, I don't know if I said negative. Negative 2 times positive 10 is negative 20. Add coming down, 0 plus negative 20 is negative 20. Negative 2 times negative 20 is 40, and that's a positive 40. 0 plus 40 is 40. Negative 2 times 40 is negative 80. And 12 plus negative 80 is negative 68. I've gone all the way to the end. This right here is going to be my remainder. Okay, so as I rewrite this, remember I started with the 7th power. My answer always starts 1 power lower. Okay, so I'm going to get an x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x to the 3rd plus 10x squared minus 20x plus 40, that's my constant, and I ran out of space, but I should have there at the end, plus negative 68 divided by x plus 2, okay? And just for reference, you can put plus negative 68 over x plus 2, or you could just change that all to a minus and just say minus 68 over x plus 2. So I'm okay with wherever you put that, okay? All right. Now, personally, I think that went a lot faster than if we do long division. But I will never stop you from doing long division. The synthetic is usually just a quicker process. That's why we kind of learn this, and only available, though, when you're dividing by something to the first power. All right, let's try one more example. And quick reminder here, this right here, we could rewrite this x plus 6, right? So that means my c is going to be the opposite sign of negative 6. So negative 6 is going in my corner. And I get, oh, this is not, okay, let me rewrite this before I start because this is not going to be good. It's going to mess me up. My highest power is x to the 4th. It was positive. Then I get negative 6x to the 3rd plus an x squared minus a 6x, all divided by x plus 6. All right, always important to get highest or lowest power. If not, you're going to mess yourself up. We also check, are we missing any powers? The 4th is there, the 3rd is there, the 2nd, the 1st. We have this 0 at the end, right, for the constant. And it's important, we need that because that's the column that our remainder comes from. You can't leave that off. Okay, so negative 6 in the corner. I have a first, or 1 is the coefficient, negative 6, another 1, negative 6, and a 0. Okay, so we need all of those there. Drop the first one straight down, 1. Then we take our corner. Negative 6 times 1 is negative 6, and we put it right there. We always add coming straight down. Negative 6 plus negative 6 is negative 12. Negative 12 times negative 6 is a positive 72. 1 plus 72 is 73. Negative 6 times 73 is negative 18. carry the 1, 42, 43, negative 438. Join with negative 46, we're adding, and I get negative 444. Negative 444 times negative 6 is positive 2,664. And yes, I used a calculator for that. All right, and 0 plus 2,664 is 2,664. Remember, this right here is my remainder. Okay, so I'm going to rewrite so I know what my actual solution is here after the division. Always one power lower than what we started with, and we started with an x to the 4th, so that means my answer should start with an x to the 3rd. So whether or not you put your 1 is your choice. You could just start at x to the 3rd minus 12x squared plus 73x minus 444 plus the remainder of 2,664 over the divisor, which is x plus 6. Okay, so there's my long division there. Okay, sorry, that's my synthetic division instead of my long division. Again, I can't stress enough, you can only use it when you are dividing by something to the first power, and you can't use it with other powers, okay? All right, last page. Okay, the remainder theorem. And I'm not sure, this is a personal choice kind of, but I want you to know it. So the remainder theorem basically says that when you divide by a number, that's the same thing as like saying I'm plugging the number in, and you get the same answer. Okay, your remainder, or I should clarify that. If you synthetic divide and you get an answer, that answer is the same thing as if you would have plugged the value in and evaluated the expression. Okay, so we're going to do this 2 different ways so you can kind of see what's going on here. I'm going to start by doing synthetic division. Okay, so I'm going to put negative 4. This is saying like x plus 4 is what we're dividing by, so I'm going to put negative 4 in my corner. 3rd degree, 2nd degree, 1st degree, no degree, so everything's in order, nothing's missing. I'm going to have a 3, a 4, a negative 5, and a 3. 3 comes straight down. Negative 4 times 3 is negative 12. 4 plus negative 12 is negative 8. Negative 4 times negative 8 is a positive 32. Negative 5 plus 32 is 27. Negative 4 times 27, negative 108, add that to the 3, and I get negative 105. So definitely a remainder. So the remainder theorem tells me that f of negative 4 equals negative 105. So whatever value you get for the remainder is the value, okay? Now, we could check this. We could do this. We could plug in negative 4 for every x in our equation, right? So we could do 3 times negative 4 cubed plus 4 times negative 4 squared minus 5 times negative 4 plus 3, okay? So, get my calculator out. Negative 4 to the 3rd power, right, is negative 64. So we get 3 times negative 64 plus 4. Negative 4 squared is 16. Negative 5 times negative 4 is positive 20 plus 3. Well, 3 times negative 64 is negative 192. 4 times 16 is 64 plus 20 plus 3. Well, I get negative 192 plus 64 plus 20 plus 3, and I get negative 105. So this is the exact same thing when I plug it in, or if I synthetically divide, I get it as my remainder, okay? So the remainder theorem's telling me synthetic divide it instead, and whatever the remainder is, that's your value when the x is negative 4. Is it faster? I don't know. If you remember the process, it's not a bad method to do it, so it's kind of your choice. I will say I don't have to go to my calculator probably as much in synthetic division, but your choice. You decide if that's good or not, okay? All right, let's try number 7, same exact way. So I'm going to put negative 13 in my box. Double check. I have a cubed, a squared, first power, and no power. So it looks like I'm in descending order. Everything's there. Coefficients only 2, negative 7, 9, and negative 3. 2 comes straight down. Negative 13 times 2 is negative 26. Add that to the negative 7, we get negative 33. All right, I'm going to admit I might use a calculator here. Negative 33 times my negative 13, 2 negatives make a positive, I get 429. 429 plus 9 is 438. 438 times that negative 13 negative 5,694, and add that to the negative 3, and I get negative 5,697, which is going to be equal to f to the negative, or f of negative 13. When I plug in negative 13, I would get negative 5,697. Still use a calculator? Is it faster than plugging negative 13 into all those spots? Possibly, but just know that this is an equivalency. So this is the big thing about the remainder theorem. All right, last problem here. Solve the equation given that negative 1/3 is a root. Okay, so one thing to know that when we have something that's a root, remember that's the same thing as saying a solution, an x-intercept, a 0, multiple words here that all mean the same thing. But negative 1/3 is a root. So what that means is I can put negative 1/3 into my corner box, okay? And I can divide this expression by that negative 1/3, okay? So I get x cubed, x squared, x, and constant. Everything's lined up. I'm going to use my coefficients, 3, 7, negative 22, and negative 8. Okay, 3 comes straight down. 3 times negative 1/3 is negative 1. 7 plus negative 1 is 6. 6 times negative 1/3 is negative 2. Negative 22 plus negative 2 makes negative 24. Negative 24 times negative 1/3, two negatives make a positive, and I get positive 8. And negative 8 plus 8 is 0. Okay, this is super important. If you get a remainder of 0, that means that you have a root, okay? And I know it seems funny to say, well, we already knew it was a root. They told us it's a root, okay? That's fine. But what this allows me to do is remember this one was the x cubed, x squared, and so on. Because I divided out that root, I've dropped my power, and I'm now down to 3x squared plus 6x minus 24 as my remaining polynomial, okay? So really, if you think about it, what I did is I factored out x plus 1/3, okay? And that factor came out, and I'm left with the rest, okay? So now I can take what's remaining, and I can divide, and I can factor, or it's a quadratic. I have 5 ways I can solve it, right? Graph it to see where it crosses the x-axis. I can take the square root. I can complete the square. I can take the quadratic formula, or I can factor it. Okay, I personally see that I have a GCF of 3, and I pull that GCF out. And remember that if this is all equal to 0, and I divide by that 3, it's just going to be gone, because 0 divided by 3 is 0, and that entire left side divided by 3 cancels it, okay? So I'm trying to factor yet this x squared plus 2x minus 8. All right, so how about factors of 8 that subtract to make 2? 4 and 2, I want my 4 positive, my x negative, okay. So, we have it all factored, okay? Remember, this told me that my root was negative 1/3. This one has a root of negative 4, and this one has a root of 2. So my solution set is negative 4, negative 1/3, and 2. Remember, in a set, it's not so important that they're all in order. It is on interval notation, but this is just a set of the solutions, okay? So I used my one root to divide down to get a smaller polynomial of smaller degree, which I could handle then with another method to solve. So I get negative 4, negative 1/3, and 2 as my solutions, as my 3 roots. So make sure if you're getting those, you say, well, it's x cubed, that means I need 3. Include the first one, and then give the other ones that you find as well. Okay? Practice the methods. Practice that division especially. Page 324, 3 through 45 by 3s. Do something else if that's what you want to use, odds or something. But I strongly suggest you practice some of this. It doesn't come as easy until you've had some practice.